So let's look at this problem, 36 divided by 3. If we want to do 36 divided by 3, we could think of that as 36 divided into groups of 3. So this is an operation of grouping. It's the opposite of multiplication, which created repetitions. Here, we're going to be taking 3's and grouping them together in one group. So let's look at 36 dots and sketch those out real quick. These are 36 dots, and if we want to group them into 3's, all we need to do is search around for 3 and then form a group around them. So we can do this working our way through the entire collection. In doing so, I'm able to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total groups. And this is why 36 divided into groups of 3 creates 12 total groups. Now this can be cumbersome when we're dealing with large numbers of dots, so one way to help make this faster is that we can look at dot division where we use dots in combination with their place values. So for example, we could put 3 dots in one box and identify this box as being tens. So each of these represents 10 in quantity. And similarly, we can create a ones place where we would put in 6 different dots. So these would be 30 and 6 dots. When we're creating groups, we still can group by those 3's. So we get one group of 3 in the tens place, and we get 2 groups of 3 in the ones place. And this allows us to identify that I have one group of tens and 2 groups of ones, making 12 total groups altogether. It's from this diagram that we get another model, the area model, one of my favorites to use for large amounts of division or representing difficult problems. In this area model, we just have to imagine that we have a rectangle where the inside area is 36. Now this makes sense because area is equal to length times width when you're dealing with a rectangle. We saw that when we did 2 times 3 and how it produced 6 total blocks on the inside of our rectangle. Well, similarly then, that means that the area, if I have identified one of the lengths, can be divided by it to produce the width. So the area can be thought of as the 36, and one of the sides can be identified as 3. And all we are trying to do is find the other. Now we can work through this in a couple of different ways. One of my favorites is to represent this rectangle where you have the tens place and the ones place. So where 3 is on the outside and 36 is on the inside, we're going to write 30 and 6 instead of 36. And that helps us see that we have 10 by 3 creates a 30 area, and 2 by 3 creates a 6 area, so we have 10 and 2 for our length. Many of us are probably familiar with the traditional method of doing division, which is to do long division. But this is a procedure that is only comfortable for us because we've practiced it a lot, not because it makes a lot of intuitive sense. For example, let's do 1,244 divided by 4. Now we have to remember that if we're going to do long division, we've got to draw an entirely new symbol. And instead of reading this from left to right, we are now going to write this from right to left. Once we have this set up, then we need to ask ourselves not how does 4 go into 1,244, but how does it only go into the first digit, the 1, which it doesn't. So we might put a 0 on top and say that 0 times 4 is 0, and that we do subtraction not of the full number, but just of the zeros place, but just of the thousandths place to produce 1. Then we do something we don't do in any other form of mathematics. We consider just a next place value and carry it down to create an entirely different number that we then repeat the procedure with. To see why this method works, let's do the dot division alongside it. So we'll put 1,244 into a place value system using the dots the same way that we did in the previous examples. 1, 2, 4, and 4. Now, if we wanted to do dot division and find groups of 4, we might start with any of the boxes. But to match the traditional algorithm, let's start with the leftmost box and recognize that because there's only one dot in it, this dot needs to be exchanged for 10 more dots in the hundreds place. Once we've removed this dot and exchanged it for 10 hundreds, we can go about finding those groups of 4. A group of 4 here, a group of 4 here, and a group of 4 here, creating 3 total groups of 4. If we return to our traditional algorithm, we can see that that's exactly what we did with these symbols. We started with just the 1 in the very beginning and saw that there were no 4s that could be grouped out of that 1. So instead, we needed to turn the 1 into 10 hundreds to partner with the 2 hundreds, and then we could consider those 12 dots as their own set, producing 3 groups of 4, which accounted for 12 of the dots and removed them from needing to have a group. Then we would move on to the next part of our diagram, where there are 4 dots awaiting us in the tens place, and we can group them all together and show there is one group of 4s. That produces 3 groups in the hundreds place, 1 group in the tens place, so 1 group of 4 accounts for 4 dots that we can remove since they've been grouped, and we have no remainder except for what's already in the ones box. And so we repeat the process one more time to take away those remaining 4 dots and have no remainder. On the right hand side visually, we can see that that produces 3 hundreds groupings, 1 tens grouping, and 1 ones grouping to give us that 1,244 divided by 4 is 311.